Hello and welcome to this afternoon's webinar, Unlocking Success in Year 12 Mathematics from Standard 1 to Extension 2, presented by Stuart Palmer and William MacArthur. My name is Caroline Paul and I am the New South Wales State Sales Manager based here in Sydney. Before we get started, in the spirit of reconciliation, Cambridge University Press and Assessment acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respects to elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people here today. First up today, we have Stuart Palmer covering changes in Standard 1 and 2. Stuart Palmer has more than 25 years' experience teaching mathematics. He is very well known by teachers throughout the state for the professional learning workshops he delivers. Stuart also assists thousands of Year 12 students every year as they prepare for their HSC exams. Following Stuart, you will hear from William MacArthur, who will be covering the advanced and extension courses. William is currently teaching at Sydney Grammar and has over 15 years of experience teaching mathematics in New South Wales schools at all levels of ability, including working with pre-service teachers. He also has extensive experience with HSC, having been involved with marking, presenting at HSC mathematics revision seminars, and most recently he has been involved with the New South Wales Stage 6 Mathematics Curriculum Review. We then have Ben Staker from the Cambridge Maths Publishing team showcasing the new exam generator, an online feature coming soon with Year 12 resources that I'm sure you will all love. Mathematics publishing manager Scott Halligan will also join us towards the end of the webinar for the Q&A section. So please feel free to submit your questions through the chat during the presentations, and the team will cover as many as possible after all the presentations. And if we do run out of time, we will get back to you individually. So with that, I will now hand over to Stuart to get started. Thank you.
Thank you, Caroline. Excuse me. Thank you, Caroline, and thanks everybody for joining us. Yes, for this new version of Standard 1 and 2, I was very happy to join the Cambridge team, my first foray into Stage 6 textbooks. Very lucky to have the solid base from the previous edition. Also very lucky to have the awesome team led by Caroline and Scott working behind the scenes. Feel very fortunate. Also very lucky, I think, that this time the syllabus was much clearer, much more clearly expressed than the previous syllabus, and that did make our job a lot easier. And we had 6 HSC exams from the previous Standard 1 and 2. And that's where I really began with the syllabus, looking for the difference between the old and the new, and also an in-depth analysis of the HSC exams for the last 6 years since the previous version dropped. Change the slide, please. This time around, Standard 1 is closer to being a subset of Standard 2. There's only a few things that I found that are in Standard 1 but not Standard 2. That number of things is down from the previous edition. That's going to make it a little bit easier for the unfortunate people who have to have Standard 1 and Standard 2 students in the same room. I really feel for you, but you were front and center in my mind when we were working on these changes. So we've tried to make that as easy as it can be for you. Slide, please. Just a couple of quick things in case you haven't heard this. During Year 11, the diamonds are gone. In the previous syllabus, Year 11, some dot points had the diamond, which was actually a rhombus, but that's gone. That means that Year 11, all of Year 11 need to do every single dot point in Year 11. Unfortunately, that means if your Standard 1 students are going to do the optional HSC exam, they need to be totally fluent with every single dot point in year 11. They are all on the table and they are all examinable. That was not the case before. Slide, please. And also the paper clips. You would know this by now, I'm sure, that the idea of common questions between Standard 2 and Advanced has gone. Haven't seen or heard anything about common questions in Standard 1 and Standard 2, but in the last 6 years there have been numerous questions that were in both Standard 1 and Standard 2, exactly the same wording, same marks, and some of those questions, well, I was quite shocked by how difficult some of them were. And we have certainly taken that with us when we put on our Standard 1 glasses. We've certainly tried to pay to do justice to that by making the hard questions in Standard 1 just as difficult as Standard 2, knowing that that's what they're going to cop if they do the optional HSC exam. Next slide, please. Changes, you should be aware of this by now. The first part of networks went from year 12 to year 11, and the other way, probability went from year 11 to year 12. So did the introduction to interest and depreciation, went from year 11 to 12. Similar triangles, anything to do with similarity at all, no mention. Venn diagrams, new to year 12 Standard 2, ouch. We've never had Venn diagrams for students of this caliber before. Not in Standard 1, but definitely part of Standard 2. Linear simultaneous equations, Standard 2 will be solving them algebraically, Standard 1 just graphically. Thank you. Next slide. Okay, what are we changing in the books? And I would say that firstly, we have included many of the features which have been popular in our 7 to 10 books. People like Ben and Scott who work for Cambridge, they go out and talk to teachers in schools and they know which features in our year 7 to 10 books were popular. And I've misspelt the word some. There you go. Ouch. We've got some new features as well, which I'll talk about in the coming minutes. New slide, please. Yeah, you would be familiar with these in our year 7 to 10 books. They are in the most recent version of 7 to 10. People like them. Not really sure how we survived over 100 years of mathematics education without learning intentions, but anyway, there they are. We're putting them into the year 11 and 12 standard books, along with past, present, and future learning, just like we have in 7 to 10. Next slide, please. In case you haven't noticed it, every single example, that little thing in the top left-hand corner there, every single example in Cambridge 7 to 10 has a spoken video with a teacher speaking and scribbling. That has now been extended to every example in year 11 and year 12. Correct me if I'm wrong, Ben, but I believe that Standard 1, Standard 2, Advanced Extension 1 and Extension 2, every single example has a teacher speaking clearly and scribbling on a screen. That's a really useful feature, I think, but often overlooked by teachers. Next slide, please. In the 7 to 10 books, when we do examples, we have a solution on the left with an explanation on the right. We're now going to be consistent with that through year 11 and 12 standard. Next slide, please. We've also followed up every single example by the thing called Now You Try. If you're familiar with 7 to 10, we did that in every example in 7 to 10 in the most recent edition, and we have continued that into 11 and 12. Next slide, please. We've tried to do the right thing by including spreadsheet activities. So there are dozens of spreadsheet activities throughout Standard 1 and Standard 2, and they are mentioned in the book, but you will also find them in the online downloadable version. Rather than just students starting with a blank spreadsheet, we often have a template that students can download and modify to finish the job rather than starting from scratch every time. And these also come with detailed instructions about what students can do. Not much of that in the book, because the fear is that in the book next week, there might be a new version of Excel. So those instructions tend to be in the online place, not in the book. Thank you. Next slide. When you get to an exercise, you will find that the names have changed: building, developing, challenging. And when it comes to the exercises, we have tried to make sure that they are well aligned to actual HSC questions. Particularly that last section, communicate your reasoning, understanding, and fluency. We did that in the Year 11 book. You might be familiar with it by now. If you haven't seen it, pick up a Year 11 book and have a look at the last part of every single exercise. There is a meaty question in the HSC. It might have been worth 3, 4, or 5 marks. Some of them are scaffolded, part A, B, C, D. Some of them are not. Some of them use the word that students like the least. Explain. Yeah. Every time that word appears in an HSC question, the feedback from senior markers is not great. Students struggle to explain mathematical concepts. We believe strongly that they need a bigger, much more practice at that on a regular basis. Okay, next slide, please. There's an example there. That one is highly scaffolded. These are from the Year 11 book. Next one, please. That's not scaffolded. I love this, where you've got to change one number in the equation so that the answer will be different. Have some fun with those. Next one, please. A mathematical trick. And next one, please. Yeah, comparing. What they're often required to do is do a comparison. Do something one way, do it another way, and then make a decision one way or the other. Next one, please. At the end of each chapter, we have key ideas and a chapter summary. Next one, please. We also have a chapter checklist with success criteria. They've been very popular in the 7 to 10 books. These are they're in the book, but they're also downloadable and printable, so that students can actually tick off to be sure that they have covered everything in the chapter. Next one, please. And multiple choice. My experience is that students who do multiple choice get better at multiple choice. They're not necessarily better mathematicians. They're just better at playing that horrible game called multiple choice. Next one, please. And short answer. And in all of this chapter review, every single question is related back to one of the exercises. Next one, please. And some extended response questions. Again, we studied HSC exams very carefully, in particular the more challenging questions in HSC exams, to make sure that by the time they finish the relevant chapter in the Year 12 books, they are really ready to tackle even the most challenging HSC questions. Next one, please. These snapshots you're about to see come from a spreadsheet. You can obviously see that. We are going to make this spreadsheet available to teachers. It shows a really good comparison between what's in the Standard 2 book and what's in the Standard 1 book. So in this chapter, by the way, there's only 7 chapters in the Standard 1 book. yeah, whoever's using that book next year, make sure they have a good look, because I think standard one is actually quite gentle, bit light on. Your teachers are going to have to pace themselves carefully. There's only 7 chapters. There's 4 terms to go, and only 7 chapters to get through. The standard two book has 11 chapters. This is chapter 10, so this is a major part of standard two, but does not appear in standard one at all, which means that students of standard one, well, they should have done networks during year 11, that introductory part, and then they don't see it again until the trial HSC. That's a long time between drinks. I think they're going to need another dose of the standard one students might need to have another good dose of networks. Anyway, standard two have got a lot more work to do. We've moved network flow to the beginning of the chapter because we think that is the easier part of the topic. And then all of the critical path analysis follows that, including the new part, Gantt charts. Now, I didn't spend much time on this chapter because I've never taught this stuff to students. You might notice there's 2 other authors on the team, Darren and Christina. Christina got this one. She was happy to take it. She's taught she's taught networks more than a few times in the last 7 HSC years, and I think she's done an awesome job. Mind you, she had a much better syllabus to work from, and she had 7 years worth of HSC questions. The new thing, Gantt charts. Yeah, that's an interesting inclusion. Not sure that I like it that much, but anyway, next slide, please. So that's, oh, sorry, go back, please. That's the first, there are basically 3 types of chapters in standard one. There's this one like this where it's in standard two, but there's nothing in standard one. Next slide, please. And then there are focus areas where there's a lot in standard two and not as much in standard one. Yeah. So this is one of the very few areas where there is something in standard one that is not in standard two. Standard one students are expected to think about water pouring into a strangely shaped vessel and then draw a graph with time on the horizontal and water level on the vertical. That's one of the few things that are in standard one but not standard two. Okay, next slide, please. And this is the other type of chapter where standard one and two are mostly identical. Yeah, in some of those chapters, what we have decided to do is to include extra sections for standard one. In my experience, standard one students really struggle with rates. And so we've taken it a bit more slowly in the standard one book. So that's the third type of chapter. Next slide, please. Yeah, basically when we were working on the standard one book, we came up with this phrase, lower threshold, same ceiling. If there is a dot point that is in both standard one and standard two, we've decided that students have to reach the same ceiling, but we've decided to lower the threshold in standard one. Next slide, please. So we did that by having fewer concepts and skills per exercise, and therefore in some chapters we have extra exercises. In standard one, there are some simpler examples, and in the exercise we have increased the number of simple questions, but they still reach the same level as standard two. When you see the standard one book in the index, some of the exercises will have these stars. That indicates, next slide, please. That indicates, next slide, please. That indicates that there are some activities in the standard one book called Are You Ready? My feeling was that standard one students might not be ready for what they are about to meet. So we have produced some things that teachers can download, modify, print, give to students that will actually get them ready for what they are about to receive. Next one, please. Right. Same ceiling. Right. Yeah, we included many of the more challenging questions from the Standard 2 book into the Standard 1 book. Some of the Standard 1 chapters really didn't go far enough, in my opinion, to prepare them for the HSC exam. We know from the last 7 years. Bad news, yeah. If you're doing Standard 1, degree of difficulty in some questions is exactly the same. Good news for Standard 2, you've got a lot more time to cover fewer concepts. Bad news, every dot point in Year 11 can be in the Standard 1 HSC exam. Good news, to my surprise, 2 years ago, a Standard 1 student got an ATAR of 93 and they counted Standard 1 in that ATAR. I was quite surprised and somewhat shocked by that. So yes, they can still get a very nice ATAR. They would need to really do very, very well in the HSC exam to do that, but obviously some students do. Next slide, please. Okay, the online resources, greater emphasis in modeling and using technology. These things are hard to do in the book, but we've got them ready to go in the online place. So building a spreadsheet, using a spreadsheet, creating nonlinear models, statistical investigations, plus we've also included new skill sheets, focusing on some of the trickier things. Yeah, including buy now, pay later, Gantt charts, etc. Thank you. Next slide. We've also written new skill sheets. These are downloadable. I think they're a lovely appendix of the book. Might be very useful for Standard 1 if you've got Standard 1 and 2 in the same room. Might keep Standard 1 busy while Standard 2 is doing the things that Standard 1 don't have to do. Next slide, please. And we've got modeling tasks. I think there is one per chapter, not quite one per chapter. These have been written by another person, not me. She's done a great job. Again, these might be good things for Standard 1 to do, while Standard 2 are doing something which is not in Standard 1. And also Standard 2, if you're still going to do non-traditional assessment tasks, then these would be great inspiration for those. I think that's it. Next slide, please. Yes, I'll get off. Thank you, everybody, and thanks for listening.
All right. Thanks for joining us, everyone. This evening, I'll be talking about Maths Advanced Extension 1 and Extension 2. I'll be going through the syllabus changes for each of these courses and talking about how the textbook has addressed those changes as well. Next slide, please. So just a few broad comments about all the syllabus documents. If you've looked at the new syllabus documents, you'll see that in terms of words, the syllabus is longer, but there's definitely not more content. In the old syllabus, the content points, similar to standard, were quite vague in some areas, and the authors needed to make a lot of assumptions about they thought what was in and what was out. And of course, they were conservative in that sense, just because, the last thing we want is something to appear in an HSC that was not covered in our books. The new syllabus, few assumptions needed to be made due to the clarity of the document. So we're very confident this time around. We've got very clear alignment to the syllabus. What this presentation covers in terms of syllabus changes, any time where the new content kind of differs from assumptions made, I'll bring that up. Obviously, anything that's new or been removed, I'll bring that up as well. And any content that has changed courses. And that's probably the biggest one, shifting content between Advanced Extension 1 and Extension 2. The vast majority of the assumptions that the authors made in the first edition of the textbook, they were correct. And plenty of, plenty of times over and over that's kind of been indicated they've done a good job with that. But yeah, it is a lot more clear this time around. But any time that those assumptions were correct, I won't just mention it over and over unless there was a bit of debate around the matter. Anytime something moved within the same year of the same course, I won't mention it then either. Next slide, please. So just on the right, you can see a screenshot of the Maths Advanced Year 11 syllabus. On the left is my take on it for this presentation. So you can see the focus area, further graph transformations and modeling at the top. I'll be going through each of the main headings. And in the pink box there, if you see a plus, that means there's new material. A minus means something's been removed. And if there's a square dot point there, that's my just kind of general comment about what's going on there. I will go through this fairly quickly because there's a lot of information here, but I know these slides and the presentation will be made available afterwards. So please, if you're taking notes, don't stress out too much if I go through this fairly quickly. Next slide, please. So in Year 12 Advanced, dilations has been removed because that's now in the Year 11 Advanced course. Modelling with functions, log functions have been moved from Year 11 to Year 12. Under sequences and series, the sigma notation for a sum, that was actually never used at all in the advanced syllabuses, which is crazy to think when we did discrete probability distributions, a sigma notation was never used, but it is certainly in there now. It's also no longer a subset of financial mathematics, so that's quite a sensible decision. Next slide, please. As you know, differentiating e to the ax, so basically anything involving the chain rule, was moved from Year 11 Advanced, so that's now in Year 12 Advanced, and all those other harder derivatives involving exponentials as well. Next slide. So under integration, it's not necessarily a new content point, but it is worth mentioning that the notation is a lot more formal in the way that a definite integral is described and the notation throughout that document. For example, the definite integral, it's not defined as being an area under a curve or anything like that. It's a much more formal definition there. Down the bottom, the area between a curve and the y-axis, that's now explicitly included in the syllabus, that's new. An area between curves is now explicitly in extension 1, so that's been removed. Next slide, please. Differentiability at a point has been included in Year 12 Advanced. It's also worth mentioning the definition in the syllabus is quite formal, and that's in contrast to the definition of continuity at a point in Year 11, which just talks about a curve going through a point. So just keep an eye on that because it does involve kind of the existence of a derivative at a point, which is a much more formal take on it. Under rates of change, acceleration, and specifically the notation d squared x dt squared and x double dot, that is now in Year 12 Advanced. And that notation, by the way, x double dot and x dot even, that was actually only in extension 1 and 2 before, but it's now explicitly in Advanced as well. Under random variables, discrete random variables, that entire topic has been moved to Year 12. And that now means we do all the stats distributions, discrete and continuous, in the same year, which seems quite sensible. Just a few extra inclusions with the notation. The mean and variance of a continuous random variable. That is now explicitly in the syllabus, and that was already in the Cambridge book. So that's one of those many cases where the right assumption was made there. The notation to call x a normal random variable, using that notation that's in the syllabus, that was already mentioned in the Cambridge books though. The next major point ties in with what Stuart was saying. There's a whole lot of common content that was removed. So I think we can all kind of breathe a sigh of relief when kind of looking at all of that content that Advanced never really kind of treated with the same degree of seriousness, I think, would be my take on it, as some of the standard students would. So yeah, I'm a big fan, I think, of common content being removed. Next slide, please. And finally, under financial maths, again with the common content, the financial tables have been removed. So yeah, good news for us. Next slide, please. All right, so this slide is a pretty confusing one, and I just want to explain what's going on here because I think it's really important in talking about the philosophy of the Cambridge books and how they've been written, and what it actually means in terms of the syllabus. The syllabus on the left, it's a very useful document, but it's not a teaching program and it's not a scope and sequence. The authors have spent a lot of time and had a lot of conversations about how to best take this content and present it in a pedagogically sound way. And if I just move over to the right, that gives you the 10 chapters in the Maths Advanced textbook. When we talk about the calculus-based courses, we're talking about what differentiation is and what integration is. And that's addressed in chapter 2 and chapter 3. So those key ideas are drawn on over and over and over throughout that Year 12 advanced course. But in chapters 2 and 3, they only do it with algebraic functions. In chapter 4, for example, you are reviewing exponential graphs. You are then differentiating exponential graphs. You are then doing an applications of derivatives. So that's all the stuff that you did in chapter 2, but now with exponentials. You then move on to integrating exponentials, and then doing all the stuff that you did in chapter 3, but now with exponentials. And that happens over and over and over to reinforce those ideas between the key ideas in calculus in chapters 4, 5, and 6. And then obviously all of the motion comes afterwards, and rates in particular, using all of those functions. Next slide, please. So in terms of the structure, this slide will probably only make sense if you're familiar with the current textbook, but the old chapter 2, graphs and equations, has been removed. Removal of the displaying interpreting data chapter, because that was common content. Exponentials and logs, due to popular demand, that has been split into 2 chapters. And obviously discrete probability distributions has moved from Year 11 advanced. But the overall take is that the book is smaller. That it's a reduction of overall volume, just because the syllabus is more clear and we're more closely aligned to it. Next slide, please. So the features of the Year 12 advanced textbook. We know that Cambridge kind of calculus-based textbooks have a bit of a reputation for pitching towards the top end, and a lot of effort has gone into making sure that we're catering to all learners in the classroom. So with those things in mind, a lot of similarities between the standard books and the earlier books as well. Learning intentions at the start of each chapter, and a goal there is to take the syllabus and split it into effectively the key skills, and students can be made aware of that at the start of each section. Summary boxes throughout that just really highlight the key ideas, and they're clearly labeled examples. We've kind of reviewed a lot of those and made adjustments where necessary. And the idea is that those solutions really do demonstrate the type of solutions that we want our students to be aiming for. Stuart mentioned this earlier, and it's true for Advanced, Extension 1, Extension 2, but yes, there is a worked example video for every single worked example that's in the book. So that's a really useful tool for revision. Also, like if someone's absent or something, there's a lot of kind of resources there to help that student get back up to speed. Next slide, please. So again, in the theme of helping diverse learners, skill sheets, as with the standard course, basically, we've got extra support here for every single exercise. And the idea is that if you've got a student in your class and they're not quite ready to move from the foundation towards the development section, there's an extra resource here where they can kind of build those key skills before moving on. All of the questions in here are quite similar to the foundation style problems. If something appears in it from the development section, an idea, then there's extra scaffolding to help them really kind of gain traction on that problem. All of the problems are tied to the learning intentions. So if they're kind of looking at a learning intention and they're not quite sure, they can look up a skill sheet problem and go from there. So the ways that this would work in practice is if, say you've got, even in the most extreme case, you've got an advanced and extension class in the same class, and you know that you've got some capable students and you've also got some students that need a bit of extra support, you could print these out for the whole topic in advance and just know that, well, you know, you can do questions 1, 2, and 3, and once you're done, I want you to do question 10 and 11 from the skill sheet, and that's going to, you know, give you that confidence to move on to those harder problems. And kind of the diverse problems in the book will mean even the strongest students can continue to work at their own pace, while those, you know, ones that need a bit more support are kind of churning out a few more foundation level problems. Next slide, please. So the skill sheets in a way go hand in hand with the skills checklist. And what we've got on the right here, I'll just draw your attention to this picture. That's from the Year 11 chapter, but all of those learning intentions have been phrased as key skills. And you can see throughout that there's references from those key skills to the examples in the textbook and also skill sheet questions. And basically, I think this really serves to provide structure, because I know we've all had students in our class that when it comes time to revise for an exam, they just don't know where to start. And I think if you give them this sheet, that is exactly where you want to start. You want to go through that checklist and make sure you can kind of tick off those boxes as you go through it. Next slide, please. The things that we are known for still remain. The kind of extensive exercises, a huge range of problems from foundation development to challenge. We've kept a close eye on the grading there and make sure it's all quite sensible. So the breadth of question alone allows for differentiated learning in your classroom, as I was saying. Even the best kids in the state in terms of where they're going to, achieve band 6, that kind of thing, they're going to find something juicy to chew on towards the end of any exercise, I think. So there is a very wide range of questions that are available for kids to kind of work on. The harder questions, well, the HSC is hard. And I know in some ways, I've never quite understood it, but some people don't like giving their kids a textbook that has hard questions in it. The last thing I would ever want for any of my students is for them to sit the HSC and find it to be the hardest maths they've ever seen in their life. So with that in mind, I think giving exposure to those harder problems is probably a good thing to do along the way. Having said that, I'm quite confident that someone could only dabble in the challenge problems here and they could quite well go on and get a band 6. So the challenge questions are tough, and just be aware of that when you are setting this work. I certainly wouldn't go in and say, oh, you do the second half of this exercise. That's probably, would need a bit more thought. Students shouldn't do every question. That would be ridiculous. With the number of questions that are there, you could spend a week on one exercise. So the idea is for them to do enough until they've gained mastery and confidence in that subject and then move on. But full well, they know that there are plenty of questions there for them to come back to and revise. Next slide, please. All right, so I'll do the same thing now for Year 12, Extension 1. First of all, just going through the syllabus. Next slide, please. So under induction, a subtle change here. It's not in the content, but there's an example there that talks about proving that 3 to the n plus 7 to the n is divisible by 10 for all odd n, noting that n increases by more than 1. So previously that was explicitly in Extension 2, but now it's an example in Extension 1, so we can only assume that that's fair game for Extension 1. Under vectors, some pretty significant changes here. Vectors in 3 dimensions has been moved from Extension 2, and that's all of the same things that you were doing in 2 dimensions, things like adding, subtracting, scalar multiplication, dot product, projections, etc. That's all in 3 dimensions now in Extension 1. Motion in vector form in 2 dimensions, a lot more detail than the previous syllabus. And just to make a point, the previous syllabus had 1 content point. The new syllabus has 10 content points on motion and vectors. And those concepts, displacement, velocity, acceleration vectors, Cartesian equation of the path of motion, and relative velocity. I should mention the Cartesian equation of a path of motion restricted to lines, parabolas, and circles. A very sensible decision is that is the same restriction that's in Year 11 Extension 1 on finding the Cartesian equation of parametrics. So that's quite a sensible kind of link between the 2 courses there. Just some other notable changes to vectors. All of the application focus works on motion. And what I mean by that is the word force does not appear in the Year 12 Extension 1 syllabus. So that's quite welcome. You don't need to worry about force resolution diagrams and stuff like that in Year 12 Extension 1. And all of the geometric results have moved to Extension 2. Next slide, please. Inverse trig functions, that entire topic has moved from Year 11 Extension 1. With the graphs of inverse trig functions, you'll notice all of these trig functions and inverses and their composites. We're now sketching all of those. All of those are already in the Cambridge textbook, but now they're explicit content points. Transformations of inverse trig functions are also in there. I brought this up because there's a subtle point here in the sense that trig functions, inverse trig used to be in year 11 extension 1, but dilations were in year 12 advanced. So dilations are now in year 11 advanced, and inverse trig is in year 12 extension 1, the implication being dilations of inverse trig functions are now fair game. So that would be easy to miss if you just thought it was a copy and paste from the old topic. It's not quite. Under further derivatives of functions, parametric differentiation is explicitly in year 12 extension 1 now. And the next point here, I've really just put it there for the notation that's been used rather than the concept, because that notation is a little bit scary looking and you wouldn't want someone to see that for the first time in an assessment, I would imagine. Next slide, please. The next few content points all reflect the idea that the year 11 extension 1 no longer has any calculus in it. So multiple zeros of polynomial functions, that's year 12 now. Related rates is year 12, and the modified exponential growth and decay model is in year 12 as well. Area between curves, I mentioned this when I was talking about advanced, but area between curves is now specifically in year 12 extension 1. Under differential equations, the topic is largely the same, but the language is a little bit different, and it's worth having a read of that just to make sure that we're kind of on the same page. For example, we don't call them direction fields anymore. We call them slope fields. The order of a differential equation, an IVP, is defined. There was an old syllabus content point, quite a strange one, that required students to identify a first-order linear differential equation, even though they didn't know how to solve them generally. So that is now removed, so that's good as well. Also, recognition that the logistic DE can only be solved in extension 1 if they're given the partial fractions decomposition, which I think we all knew, but it was good to have it in writing anyway. Next slide, please. So under the stats side of things, again, notation, if we're talking about a binomial random variable using X to denote a binomial random variable, that's already in the textbook, but it's in the syllabus as well. Central limit theorem is new to the year 12 extension 1 course, and normal approximation to a binomial has been removed. Central limit theorem will be an interesting thing to assess, I think, because a lot of the time we're effectively doing problems on the application of it, but the syllabus does make very clear that they need to understand what the central limit theorem is, other than the fact that, normal distributions are great because they always work. There's a bit more to it than that, and that makes it clear in the syllabus as well. Just lastly, some broad things that will pop up when I talk about extension 2. Products to sums has been removed. I bring this up because products to sums, you would use those in the old trig equations content in year 12 extension 1. T-formula has moved to extension 2, and the auxiliary angle method has moved to year 11 extension 1. Next slide, please. All right, so on the right-hand side here, there are 18 chapters in the year 12 extension 1 book that includes all of the advanced stuff. And you can see how the syllabus maps across. Everything's got its own little chapter, with the exception of areas of compound regions. And you can see we've snuck an extra exercise into chapter 4 in the advanced integration chapter. So what that means is that when students progress through integration doing the advanced content, they'll do area between an X and a Y axis. And the next exercise after that is area of compound regions, which is a fairly sensible time to cover that material. Vectors has been split, as you can see. The main reason for that is because the vectors and motion is quite different compared to the rest of the vector stuff involving dot products and projections and things like that. Vectors and motion also includes projectile motion, of course, and also further applications of calculus. That gets addressed in kind of the key skills component, which is chapter 13, and chapter 14, differential equations. That really does warrant its own chapter. Next slide, please. So again, with the extension 1 book, we've really put a lot of effort into making sure that we don't go over the top in terms of the content, and making sure that we're catering to all learners in the classroom. All of the worked examples have been reviewed, extra steps added into the worked examples, extra examples where needed to kind of clarify a few ideas, and just the explanations in general have really been reworked to kind of make it a bit more accessible. As with advanced, learning intentions at the start of each section, skill sheets for every topic, skill checklists and videos for every worked example. So we're really kind of trying to make sure that no one feels left behind as they kind of take on the challenge of this Extension 1 course. We know, if someone might pick Extension 1 and the only reason is that they really want to be an engineer, and we just want to make sure that even though maybe they struggled in year 10 or something, that they've got as much as they possibly can to help them get through this difficult course. Next slide, please. So, as always, we just want to make sure we're still continuing to extend the most capable students in our classroom. So as a way to kind of explain what we're doing here, I've just got a side-by-side comparison of the curve sketching using the derivative chapter in the Advanced and Extension 1 books. In the Extension 1 book, you'll notice the advanced chapters aren't exactly the same. There's a few more explanations that are a bit more abstract and extra problems in the exercise as well. And in this case, you'll notice on the right, Chapter 3C and Chapter 3J are actually new exercises that aren't in the advanced book, if that makes sense. And they're just a bit more abstract in the way that they apply those advanced techniques, but not necessarily what we'd be expecting our advanced students to be doing. But again, that does mean that if you have students in the same class, some of them doing advanced, some of them doing Extension 1, the Extension 1 book, the advanced chapter might be a little bit different in the sense that there's a few extra problems there to chew on. Next slide, please. So Year 12 Maths Extension 2, I'm conscious of time here, so I will go through this pretty quickly, but there are some pretty significant changes. Proof. The notation throughout is a lot more formal. We're now using capital letters to denote statements. That's never in the previous syllabus, but it did appear in HSC exams, so it's good to get that clarification. The notation throughout for and, or, and negation, we're now using that in symbols rather than words. So it is clear that it's a lot more rigor, I guess, in the previous treatment. Down the bottom here, negation of statements is now explicitly included. The first one there, the negation of a negation, I think that's pretty obvious. The next one, known as De Morgan's laws, although the syllabus doesn't actually call it that, they're explicitly in now. And the last one here, that is the negation of an implication. I am personally so glad that they brought that up because to me, that result is not obvious at all. There's a lot more going on behind the scenes in terms of formal proof. So the fact that they've said that it is in the course, I'm glad they said it. If anyone knows, the 2020 HSC question 8 multiple choice in Extension 2, that was the first year of the new syllabus, and there's an absolute ripper of a question there that involves negation of an implication, and I dare say that that took a lot of students by surprise. So the official inclusion now, I think it kind of in a way creates a level playing field in the sense that we know we're covering it. Next slide, please. Illustrations of proof are largely the same. That's where your proof by contradiction, contrapositive, that kind of thing is all in there. In inequalities, explicit inclusion of the squeeze theorem, that's already in the Cambridge text. And if you look through the last 30 odd years of HSC questions in Extension 2, there are so many beautiful questions that actually do use the squeeze theorem. And it's just kind of relying on intuition there, but now it's explicitly covered. Under induction, I mentioned this before, but n not increasing by 1 is no longer explicitly Extension 2. That can appear in Extension 1. So I guess that's a removal, but it could still appear in Extension 2. Extension 1 induction was restricted to sums and divisibility. Extension 2 is far more broad, but largely I don't think there are many changes to the previous syllabus. Next slide, please. Under vectors, as I mentioned, vectors in 3D, that has now moved to Extension 1. Vector equations of lines, we're now defining skew lines. That's actually already in the Cambridge text. A very subtle point. The previous syllabus had a content point about identifying whether or not intersecting lines are intersecting lines are perpendicular, I should say. That point is now removed. So it's possible now to have a situation where you've got two lines that have perpendicular direction vectors, but they're not perpendicular because they don't intersect. And that's quite subtle, so just be aware of that. Under vectors and geometry, the Cauchy-Schwarz inequality for vectors, that is now explicitly in the syllabus. Again, I'm very happy that they mentioned that because it's a natural idea that appears if you're looking at the dot product. And I've got their question 16A part 2 from the 2021 HSC is just straight up the Cauchy-Schwarz inequality. So again, it's good to know that the kind of playing field has been leveled there. We've all seen it. Proofs of geometric results in 2 and 3 dimensions, that's moved, well, the 2D part has moved from extension 1. I just wanted to give a shout out there to the teaching advice section because there's a very long list of contexts that you can use for those geometric result proofs. Most of them are in our book, but just be aware that that is a very useful list to look through. Next slide, please. So under complex numbers, classifying numbers into their sets, natural, integers, rationals, reals, complex. That's now specifically in the syllabus. The teaching advice basically suggests not to go near the ambiguity regarding the inclusion of 0 in the natural numbers. But in the teaching advice, they've used Z plus and Z plus with the union of 0 as a way to kind of avoid that ambiguity there. Moving down, explicit mention of the geometry of the nth root of plus or minus 1 is now in the syllabus. The previous syllabus only mentioned roots of unity, so now we've got roots of minus 1 as well in that same depth. A large change overall, which might be controversial for me to say, but I'm happy about it, is that Euler's form has been removed. Next slide, please. So I mentioned this earlier, but products to sums moved from extension 1, T formula moved from extension 1, and I think a really important point that could potentially be overlooked is that these content points appear in the integration section of the extension 2 syllabus, but there are plenty of things that they have to do with them other than integrate. So the examples I've got here, we're solving a trig equation using a reversal of the products of sums results. And the next one, they're effectively using a T substitution, and you've got to check for pi, which turns out pi is a solution there. It's not going to pop up. Those integrals right at the bottom there as well, involving products to sums, they're explicitly in the syllabus now, but all that stuff's already in the Cambridge book. Next slide, please. Partial fractions decomposition. We've got perfect square denominators have been included now. That's not in or out, it's vague, but it's worth mentioning that that didn't appear at all in the last 6 years worth of HSC papers. So again, good to get that clarity. The next content point is a syllabus. It's an example from the syllabus, and I just wanted to bring it up here because it's just partial fractions, but I wanted to mention it because it's really annoying. If you have a look at how that quadratic factorizes, that's an example from the syllabus. So we do want to make them do annoying questions, basically, is what I'm getting at. So there's nice, easy cases, but then we've got stuff like that to deal with as well. The teaching considerations mention that we're not using these kind of integrals from the old pre-2017 standard integral sheet. I've heard a lot of people say, oh, who cares? They're just random integrals. I did just want to bring up, because most people think, who cares about these integrals? In mechanics, if you have a falling object, resistance proportional to the square of speed, if you want to find a relationship between x and t, the easiest way to do it is to reduce an integral to the one I've got there at the bottom, the integral of du over root u squared plus 1, using a substitution, and from there you just invoke one of those results. So it's probably not going to appear in an HSC. I think they've made it very clear that they don't expect students to see it. But I bet you if it ever does, that would be the context in which it pops up. That would be my prediction. Those integrals appear in our books twice. Once in a question where it says differentiate, hence integrate, and then another one where they're using a trig substitution, but certainly it's not something we want them to memorize. Next slide, please. Under mechanics, forces, as I mentioned, removed from extension 1, now explicitly in extension 2. Simple harmonic motion, we've got a new form for displacement there alongside the old ones. We've also got this result for v squared that's in the syllabus, and it's also on the new reference sheet. I'm very happy about that. Something that really baffled me a few years ago. There's a question, 13D in the 2021 HSC. My reading of the question is that you're actually meant to derive the results. If you actually open up the HSC marking guidelines, they quote this result for v squared and then sub into it. And I would have thought that that was a big no-no. So I'm very glad that they've included that now and given us some clarity that that's actually fair game to quote that result. Under modeling motions without resistance, pulley problems are specifically included. I was terrified when I first saw a pulley pop up in the first year of the HSC, but there it was. Again, good to get that clarity. I'll talk a little bit more about pulleys on the next slide. Smooth inclined plane problems are also specifically included. And there was a bit of a ninja edit to the syllabus 2 months ago today. It used to say that you solve those problems by resolving forces parallel and perpendicular to the plane, and now it just says resolving forces, which I think is quite sensible because sometimes it's just easier to do it vertically and horizontally. So yeah, just a bit of a ninja edit there, but it is kind of good to know that that happened. All of those concepts did appear in the last 6 years of HSC, but I think they were perhaps a surprise when they did pop up, but now they won't be. Next slide, please. Rectilinear resisted motion. Just the sigma notation there for the sum of all forces acting on a particle is new. There's a content point here that explicitly removes pulley problems from a situation where they experience resisted motion. And as I mentioned, 2020 extension 2 HSC 16A, it actually had a pulley problem where you had two masses and each mass was also experiencing air resistance. So that was a bit of a tricky problem for sure. But according to the new syllabus, that is not fair game anymore. And perhaps I'm being too pedantic here, but that same syllabus content point that excludes pulleys from resisted motion does not exclude inclined planes. So just keep an eye on that. I would expect that something moving down a plane experiencing friction, that to me is fair game. Down the bottom, projectiles and resisted motion, the removal of overlap with the extension 1 is that's good. Resistance of a projectile moving in 2 dimensions is now specifically proportional to speed rather than the second power of speed, which actually has a set of DEs that can't be solved. So that's sensible to remove that. And there's a new content point about comparing the path of a projectile with and without resistance as well. Next slide, please. All right, so it's all pretty sensible in the sense that Extension 2, it's its own standalone book. Complex numbers are split into 2 chapters, as is our current textbook. And the new edition really is further integration has been split into Chapter 5, trig identities, and then Chapter 6, integration. Chapter 5 is 2 exercises. Very short chapter, but the first one covers products to sums and the second covers t-results, and all of the problems in those don't involve integration. So as I mentioned, they're just using those results to solve some of those identity style problems, solving equations, stuff like that, but they're not actually a part of integration, even though they're in the integration syllabus. Next slide, please. So this is my last slide, but I just want to talk about some of the features in the Extension 2 book. As with the previous textbooks, there's a big range of problems graded into foundation, development, enrichment, a whole lot of new problems here to reflect the new style of the syllabus and the language that they're using. Detailed examples with the solutions throughout, and as we've mentioned, there's a video for each worked example as well. This is a quite rigorous maths book in the sense that the maths is, this will stand someone in good stead as they go to university and study maths there. There's nothing in this book that they're going to come across in university and be like, oh, that was wrong. That wasn't quite right. The language is precise, but at the same time, it caters to all learners in the sense that we've got some solid foundation problems there for them to work on. A rigorous approach to mathematics. Dave Sadler and Derek Ward, that is really their bread and butter. They really want this to be a solid maths book, and I am actually really proud of what this is and what is kind of going to be out there. A lot of extra questions have also been written, and those extra questions a lot of the time are inspired by past HSC problems that have a bit of maybe a weird context or just a bit more explorative in nature. That seemed quite unfamiliar. So we've kind of made an effort to look at those previous papers and try and write some problems that are maybe not quite what you would ordinarily expect. So that's all from me. Thanks for staying for this long. I'll be around to answer some questions as they appear at the end. Thank you.
Okay. Thank you, Billy. And thank you, everyone, for attending this afternoon. So, yeah, my name is Ben Staker. I'm a math publisher at Cambridge, and today I'll just be talking about one of the new major online features for the whole Stage 6 series, and that's the exam generator. Next slide, please. So I'm going to start by saying 2 things that are really obvious to everyone, and that is exam practice is important, and exams are incredibly stressful for students. That's pretty obvious, but it's also a really stressful and busy time for teachers. Exams are evolving over time. Standard 1 and 2 are featuring harder questions, more on scaffolded questions, and students really need to become familiar with exam conditions. So, using their equipment, that pen to paper connection to be able to actually write for an entire exam, practice their time management skills, communicate their reasoning, and working out. And also for the exams, a lot of recall is needed. Around 25% of every single exam uses Year 11 concepts. And that's why it's really important to have a lot of practice sessions for students to kind of get comfortable with, sitting exams. Next slide, please. And that's why we're really proud to be releasing the exam generator along with the Stage 6 series this time around. So with the Year 12 books in Term 4, this tool will be live. It will also be available for Year 11. And essentially, it's a tool for creating custom practice exams from a large bank of past NESA HSE questions, so the actual questions from the exams, together with a whole bunch of additional HSC style questions that are written by experts. It's going to be updated year on year, and something that's again that we're really proud of is that this will be included within the online teaching suite at no extra cost, so all within your Cambridge resource. Next slide, please. So starting off, past HSC exam questions. So seeing what's already been out there is really important. And that's why the tool will include every HSC math question from the last 5 years. And that's for every single subject, Standard 1 through to Extension 2, because it's really essential for students to get familiar and prepare for their trial and final examinations. This will be updated every year with the latest exams. So currently, when it releases in Term 4, you're going to have 2025 to 2021. And then when the 2026 exam comes out, we'll go through that. Solutions will be created for it, and then that will be released ready for use at the start of 2027. And all these questions are mapped to the syllabus as well. So when you're looking for questions to add to exams, you're not going to have to filter out content that's not relevant. Everything that is relevant to the current syllabus will be included, and everything that's outside the syllabus will be excluded for you already. Next slide, please. Then in addition to those HSC official questions from NESA, we're also going to have a huge bank of extra authored questions. And these are written by HSC experts. And by HSC experts, really we're talking about, these aren't just uni students. These are people, practicing teachers that we've employed to do this work. People who are really familiar with HSC marking, have experience with marking, as well as creating exam material for their schools, writing for trial papers and the likes. So this is literally hundreds of extra questions, with even more being added over the lifetime of the series, that are meant to kind of give targeted practice for students of all abilities, but also common pitfalls, recurring question types that are common for the HSC, and then also new syllabus areas. So with this new syllabus, there's a few topics where the density of questions will be quite thin for a few years till we see those questions coming up. And this tool will kind of help address those gaps as well, and all with work solutions. So the authored questions and the NESA official questions will all come with the work solutions, marking guides, and everything will be mapped clearly to the syllabus. Next slide, please. So for anyone familiar with the assessment hub for building tests on Hot Maths, it's quite similar. So at the top level, you'll be able to have a variety of filters. So you can search by syllabus or focus areas. You can keyword search, choose where the questions are coming from. Are they HSC questions or Cambridge style questions? What year do you want them to come from? And then you'll be able to generate your questions in the bottom left, and immediately they're all color coded. So you'll be able to see what band is the question estimated to be, what type of question is it, what syllabus focus area does it come from? And then you'll just be able to easily select and add questions to your own custom exam, automatically or manually split into section 1 and 2. You can drag and drop to reorder tests. So if you don't like the order of the 2024 test, you can change that and it'll take minutes instead of a long time. You can save, preview the test, share it with other teachers who are using Hot Maths at your school, assign them to students, and then export them. Next question, please. Next slide, please. And that exporting part is where makes me excited about helping teachers, is the formatting. So this will generate printable exams in PDF or Word format if you want to make more edits. And they're generated exactly kind of as you'd expect from an official exam, a trial paper or an actual HSC exam. So you'll get a cover page, student name, class, all the marks for the questions that you've added will be automatically added and allocated correctly. The time that's been allocated to each question will be added to the cover page to create an official exam. Sections will be generated as you've selected them. So if you want a section 1 and 2 test, that will all be done for you. And then working space. So all the questions will have all the working space that was intended from the original question, just like they appear in the actual HSC exam, and all formatted correctly so that you aren't getting weird, janky problems with questions breaking over pages funny. It really is just like in the exam. And the goal here was to save literally hours of formatting. We talked to a lot of teachers who take screenshots and try to edit the PDFs to make their own kind of practice material for students. And we just wanted to cut that time out. Instead of hours, do it in minutes. And when you generate your test, you'll also get a printable solution and marking criteria. So for each of those questions, you'll see the work solutions plus the criteria for marks that from the HSC reports. One more feature too is that if it's online, if you're a teacher within the platform and your students are all on the platform, you can also make the tests multiple choice only and then set those as auto-marked assessments within the HotMaths platform that your students can then work through, and then as they finish, automatically have those results added to the reporting hub of HotMaths. So hopefully this saves everyone a lot of time. Even at a minimum, if you jump in year 12 when this comes out and create the exams for the last 5 years but without any of the syllabus content, I think you'll kind of be winning. Next slide, please. So some of those benefits again, extra questions written by experts that are continuously updated and added to throughout the life of the series. You have complete control over the ordering of the questions, what questions you want to remove or add, splitting them into sections so that they create essentially exactly like a real exam. A lot of quite detailed filtering within every subheading of the book. You get to see the questions, and it's all free. It's all within the online teaching suite, which is complimentary for any school that's using the resource. But yeah, so that's the exam generator, and that's the end of the presentation so far. So now we're just going to jump over and do a little bit of Q&A with the time that we have remaining. Are you there, Scott?
Yes, Ben.
Okay, starting off, I know we're a bit over time, so maybe we'll just do a few of these and then we'll obviously answer any questions that you put in the chat as well and get back to you via email. So maybe starting for Stuart, given that the standard 1, so if I have a standard 1-2 class that's mixed together, what do you recommend that I do with my standard 1 kids when I'm doing networks again?
Well, I have a feeling that the standard 1 students may have forgotten the networks work they did in year 11. So perhaps you could do that again. Perhaps they could be doing all the HSC with the exam generator. I reckon you'd be able to find all the HSC questions which are relevant to standard 1 and exclude the ones that are relevant for standard 2. It would be great for them. We've got 7 years worth of that. It would be great for the standard 1 students to have seen every single standard 1 networks question for the last 7 years. There's also the prospect of getting them to do an investigative style assignment, which may or may not be an assessment task. My favourite example was going on a trip around Australia and you had to visit one of the big things in every single state and territory, including Tasmania. The big prawn, the big pineapple, and then costing the trip of getting around and seeing all the big things. Yeah, I think I've answered the question.
Just to add to Stuart's points there, Ben, very quickly, in relation to investigation style activities, The modeling tasks, spreadsheeting, use of technology applies to Standard 1 as it does to Standard 2. And for all the common topics that are in Standard 1, we have simplified versions of those activities for Standard 1 as well, including all of the teacher notes and solutions on all of that as well. So there's opportunities for those activities, as Stuart mentioned.
Yeah, Scott, actually, just another question I think related to that though. So modeling tasks, so those all have a rubric and suggested solutions as well?
Yep, that's exactly right. Pretty comprehensive, and all of the spreadsheet activities have versions of those spreadsheets that we make available to teachers that have the completed versions in there, so that they can see what it should look like before they give the task to students.
Teachers might like to talk to your Cambridge consultant to have a bit of a sneak peek at some of those modelling tasks. I think they are finished, are they not, Scott?
Yes, they are. Yep.
Okay, excellent. So here's another question for you, Billy, from Jayanthi. So they've said, I feel a little bit lost sometimes around DEs, particularly with the terminology around isoclines. Does the new text make this clearer?
Yes, I think so. So isoclines is one of those things that they don't form a key part of differential equations, but it's the type of thing that you would probably want someone to see if they were to go and study kind of tertiary mathematics and that kind of thing later on. I do think overall the theory is just much more clear this time around. So while that's true for isoclines, I think that's true for pretty much the entire book. That was kind of some deliberate efforts this time around to kind of, we know that the maths here is hard, particularly with those newer topics. Maybe you didn't do them in university and you didn't do them in school and now you're teaching it. So yeah, we're definitely aware of that, and kind of all of the worked examples and the theory has been reviewed.
Yep, cool, thank you. Stuart, another one for you. Would you be encouraging your Standard 1 students to do the optional HSC?
Yes, I've had this question many times since we've had this optional HSC exam for Standard 1. I think I'd be working really hard to encourage them to not do the HSC exam. Lots of reasons, but most particularly, there are some dot points that I think are really valuable learning for Standard 1 students. And there are some dot points where I just shake my head and wonder why a Standard 1 student would need or want or be excited about learning that particular thing. If they're not doing the HSC optional exam, then I would feel more comfortable about brushing some of those things under the carpet somewhat, without the fear of the big scary exam at the end. And as I said, I was quite shocked by the degree of difficulty of some of the questions in the last 7 years of Standard 1 exams. I think I've answered your question, but if someone was to get in contact with me and follow up on that, I'd be happy to have a conversation along those lines.
Okay, just maybe one or two more. Just a quick one here I see from Laleen. So for exam test generator, are the questions from past HSC papers or new sets of questions? So both those will be available. So you'll have all the past HSC paper questions for the last 5 years, plus a whole new set of questions, and that will be updated year on year. And then just maybe one last question for you, Billy and Stuart, to weigh in on, and that is from Jason, who's asking, slightly outside of the scope of this discussion, but there has been plenty of chatter about changes to the answer booklets for HSC Extension 1 and Extension 2 for 2026 onwards. As far as I can see, it is mostly formatting with the flexibility of question creators to embed diagrams in questions other than question 11. Thoughts? Do you have any thoughts about that, Billy?
Yeah, I do. I completely agree with your observation. It was I was really confused when that came out because I went through everything trying to figure out exactly what had changed. But I think you're completely spot on. There's been a few exams in Extension 1 and Extension 2 where they write in booklets, but they've given specific booklets, and then they've had a diagram and they want you to annotate it or something like that. And I think they're kind of just giving themselves the opportunity to do that whenever they want now. But in terms of the actual structure, I don't think it means much in terms of how we would accommodate, other than that, maybe we want to write our exams like that as well. Just don't rule out a situation where we give them a diagram, but we just need to make sure that, it's done in a sensible way. And I think really that's what I took from it anyway, looking at their sample assessment booklets.
Yep, I think that answers the question. Thank you, Billy. Okay, I think I see a lot of people asking questions about availability. So I think given that we're a little bit over time already, I think that's a good time to finish. So I'm going to pass over to Caroline now to wrap things up and talk a bit about when the books will be available. Thank you, everyone, for attending tonight, and have a great night.
Thanks, Ben, and thank you, everyone, and thanks to all the presenters today. That has been really fantastic. Lots of information there. So just to finish up, I thought I would just run through a couple of things. For those who already use Cambridge resources in the school, you would know that we offer the Teaching Suite complimentary for every teacher to have access to. You will have a huge range of different resources, as you can see on the screen here. PowerPoints for every chapter, work solutions, everything sort of sits in your Teaching Suite, as well as the great new exam generator that Ben talked about. So yes, if you're using the Cambridge books in the school, please get in touch and we'll make sure everyone has access to these. Next slide. So what we offer for all the courses is first of all, a print book with the interactive textbook included. So within the print book, there is a code. Students can activate that, have access to all the extra interactive material. You have got the option of digital only. So for those schools who do not use print books, you can opt for that. And then, like I said, the Teaching Suite is completely online and complimentary for Cambridge schools. Next slide. So what we have for you now, which we are getting asked a lot in the chat here, which I'll answer right now. So currently we have a whole range of different planning documents. We've got sample pages, both print plus online samples that we will share with you. A lot of those modelling worksheets that we talked about and other skill sheets and things like that, we also have that we can share. And then we actually have online digital samples, so you can log in and experience the platform before it's published as well. So please reach out to myself or anyone on the team for the pricing. We're happy to talk to you about that. All the books will be available from early September. So that's when they've finished and published, as well as all the online material. But myself and the team more than happy to supply you with all the samples you need before the books are published. So please reach out. So that is the end of the webinar. Thank you all for sticking around, and have a good night, and we'll talk to you soon. Thank you.